Hello PreCalc. We're looking at 913's video. So that's a Tuesday evening or a Tuesday after class. And we are going to study the 6 trig functions today and use them a little bit. Hopefully you've seen them before in your geometry year. So let's see if this looks familiar. Call it the trig functions. So hopefully you have your comp book at home. So let's see if you can fill this in, the trig functions. All right, let's go ahead and draw a right triangle. The trig functions only apply to right triangles. So a right triangle has a right angle indicated by that little half box there, and an angle that we're interested in, and that I'll call theta. Get used to that symbol. It's often used for angles. So we have theta and we have the right angle box right here. So now each side of the right triangle has a name, and when this one across from the right angle is the hypotenuse. And you've seen that word before. When you use the Pythagorean theorem, we have had side A and B and C, and the side C is the hypotenuse across from the right angle, and back then we saw that A squared plus B squared equals C squared. We'll need that a little later, so I just thought of it by way of reminder. So you can put that in your formula page if you find that it doesn't come instantly, if you'd forgotten it. This is the hypotenuse. This across from the theta, opposite it, is side opposite. And right next to the side theta, but not the hypotenuse, the other side, is side adjacent. Adjacent means next door to. So in class, who is adjacent to you? Who is right next to you? That's the word adjacent. So the trig functions are going to be ratios created by use of these sides. So we call the first one the sine. S-I-N-E is the actual name. The nickname is S-I-N, pronounced sine, no sin. So we have sine of theta. And that is always whatever the length side opposite is divided by side hypotenuse. That's the sines function's definition. It is the length of the side opposite divided by the length of the hypotenuse. Cosine is a different. Cosine's full name, I use the abbreviations. Cosine is side adjacent divided by hypotenuse. Tangent and tan theta is opposite over adjacent. So we have using up all the different sides that I have identified in the right triangle. Now each of these trig functions has a flip of it, but before I go there, these have to be committed to memory. And there are some ways that I've seen that done. I do not recommend any of the ones I've seen. So you can become really, really famous if you can think of a memory that will nail this for people. Here's the one that most people use. I have room down here, SOHCAHTOA. And SOHCAHTOA is just a name, maybe an Indian name that they've made up that helps us remember that sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. However, I do not find that very helpful because I can't remember how to spell SOHCAHTOA. I could just as easy remember sine is opposite over hypotenuse and so on. The other one is if you can remember this order, sine, cosine, and tangent, Oscar had a hold on Arthur, which I think is also kind of awkward to remember. O for opposite and Oscar, H for hypotenuse, A for adjacent, H, O, and A. Oscar had a hold on Arthur. I did not make up these. These are actually famous ones that many trig students have employed. But, like I said, I don't think they help that much. So I've never really thought of one on my own. But whichever. You need to learn the three trig identities, or trig functions, and now we will also do their reciprocals. So if you turn sine on its head, you have hypotenuse over opposite, and that is called cosecant. And its symbol is CSC. So cosecant theta. These names always have an angle with them. All right, then if you flip cosine on its head, you have hypotenuse over adjacent, and that has a name, and that is secant. And its nickname, or its abbreviation, secant theta, SEC. And lastly, if you flip tangent on its head, you get adjacent over opposite. And that is called cotangent. This is a reading of it in parentheses. But we're going to use the symbol cotangent theta equals adjacent over opposite. So, sine, cosine, and tangent, cosecant, secant, and cotangent. We're going to use these today to do a problem or two. So with those still up, let's look at what a problem might look like. Suppose I give you a right triangle, and I give you theta, and I give you two sides on the right triangle, and I ask you to find the 6 trig functions from theta. So I want sine of theta, cosine of theta, tangent of theta, as well as the flip, cosecant theta, secant theta, and cotangent theta. In order to do that, I need to have a number for all 3 sides, and this is where Pythagorean theorem comes in, where this is A, B, and C, so A squared plus B squared equals the hypotenuse squared, so I'll call it C squared. So 4 squared is 16 plus 9 from 3 squared gives me 25 equals C squared, or C equals the square root of 25. When you take the square root of both sides, you see that side C is 5. So I'm going to put that in my drawing. Now I can compute the 6 trig functions. So the sine of this angle is going to be the opposite side divided by the hypotenuse. Opposite is 3, hypotenuse is 5. I can easily go and do the cosecant as this time because they're reciprocals. All I have to do is flip the sine value. Cosine is adjacent over hypotenuse. So from this angle, this is side adjacent, hypotenuse. 4/5, so secant is 5/4. And lastly, tangent is opposite over adjacent. So we have opposite over adjacent. Oops, wrong triangle. Opposite over adjacent is 3/4. And so the flip is 4/3. So any triangle I give you, you can establish the 6 trig functions for those. I think I'll end right there. It's better that you see this introduction and then use it before I start piling on some more relationships. So we'll save that for another day. So hopefully this looks somewhat familiar to you. If not, I've taught it as if it wasn't familiar, so now it is. So I will see you in the morning. Have a good rest of the day. Bye.